Hello, today we're looking at group 1 of the periodic table. There they are listed on the left hand side of the screen there, but if you look actually on the periodic table and look at an outline of it, you'll see they are right there at the beginning end of the periodic table, group 1. Okay, so what we're going to do is have a look at a quick summary of what they are on this page. So the first thing is they are called the alkali metals because they make alkali when they react with water. They're very soft. In fact, you can cut them with a knife. They are also very reactive and react with oxygen and water quite easily. And the atoms that make up these group 1 elements, they all have 1 electron in the outer shell. Now, we've looked at this before, but this is a key thing about these elements, and that's what determines the kind of reactions that they carry out. So 1 electron in the outer shell. So just as a quick recap, lithium would be 2-1, have an arrangement of 2-1 of electrons, 2-8-1 for sodium, and 2-8-8-1 for potassium. And we've looked at why we write electron structures out like that before. So what we're going to do for the remainder of this video is to look at the reactions of group 1 metals in 3 different conditions. The first thing we're going to look at is the reaction with with water. I think we're doing oxygen first actually. We're going to look at the reaction with oxygen first, then with water, and then look at the reactions with a group 7 gas, what's called a halogen, and that's the example of chlorine. And those are the 3 reactions that we're going to look at. So we're going to look at oxygen first, then water, and then chlorine. So how do they react with oxygen? Well, these group 1 elements are very reactive, and in fact, as soon as they hit oxygen, as soon as they make contact with oxygen, they react pretty much immediately. So if we take, for example, some lithium and slice it with a knife, which you can do because it's very soft, when you expose the metal, it looks very shiny, but it's so reactive that within a few seconds it will tarnish, it will react with the oxygen in the air, and you'll get something called lithium oxide, or the metal oxide, depending on which one you're looking at. But we can actually speed this reaction up even more and take it to more completion by using a Bunsen burner. So here's our lithium. You can see there, that's the lithium metal. We could put it on a heat-proof surface, for example, this thermal brick, and heat it with a Bunsen burner. And what would happen is it would react with the oxygen very quickly, and you would end up with a much faster reaction. So this heat would speed up the reaction, make it go much faster. And what you would see is some lithium oxide, and it looks a little bit like that. It's basically a white powder and has the appearance as you can see on the screen there. Okay, so lithium oxide. You'd get a similar reaction with sodium, but it would be a stronger reaction, it would be a faster reaction. In fact, it would actually start burning by itself almost when you use the Bunsen burner, and the reaction with the next metal down, potassium, is even stronger still. Okay, and for that you would get potassium oxide. So sodium oxide when reacting with sodium, lithium oxide when lithium reacts with oxygen, and potassium oxide for potassium. Now, this is a good opportunity to recap on balancing equations. So let's take an example of lithium. Lithium is Li. If we react it with oxygen, which exists as O2, that will make the compound lithium oxide, which is Li2O. That's the formula for lithium oxide. Now you can see this is unbalanced, so you can have a pause here, have a go at balancing it yourself as practice, and then you can come back and check the answer if you want to. If not, just keep watching, and we're going to go through it now. So the problem here is we've got 2 oxygens on the left and 1 on the right, so we can add a big 2 in front of the lithium oxide. That gives us 4 lithiums and 2 oxygens. That solves our oxygen problem. So we've got 2 oxygens, but we still don't have enough lithiums on the left. So all we need to do is add a 4 to balance it out with the lithiums on the right. 2 Li2s make 4 lithiums, and then obviously we need 4 lithiums on the left. Okay, so these are reactions with oxygen. Just a reminder as well that as you go down the group, the metals are more reactive. So as you go down group 1, they become more reactive. The next thing we want to look at is the reaction with water. So I've got a couple of sort of simple animations to show this, but the first one we'll look at is the reaction with lithium with water. And what we have is basically the lithium will float on the water, it will move around on the surface, unusual for a metal to float, As it reacts with the water, it will get smaller and smaller, and we will get the giving off of hydrogen gas. If we look at the reaction of sodium, sodium is a bit more reactive, it's further down the group. It gets smaller much quicker, bounces off the sides a little bit, and reacts a bit faster. The reaction with potassium is the strongest. This does actually move around on the surface there, but it also catches fire. The hydrogen that's given off catches fire and burns with a lilac flame. Okay, so those are the three reactions there. Now, the other thing to mention also is the reaction of the metal with the water leaves the metal hydroxide. So if we put some universal indicator in there, the metal hydroxide is an alkali. So the universal indicator will show that the solution left is alkaline, and sodium or lithium or potassium hydroxide are all alkalis. So let's have another little practice at balancing an equation, at the same time looking at what the reaction is. We've got sodium plus water gives sodium hydroxide and hydrogen gas given off. Okay, so you can pause here and have a go at balancing it if you like, which would always be good practice, but if not, I'll go through the answer for balancing now. So it's the hydrogen there that's causing a little bit of an issue. So if we put a 2 in front of our NaOH, that sorts out the hydrogen. If we put a 2 over there on the left, so that's 4 hydrogens on each side, we've got a problem with the Na. We need to have 2 on the left hand side, so we can put a 2 in front of it there, and that is balanced. Shot off the screen really quick there. Okay, so the last set of reactions is a reaction with chlorine. So we've got some chlorine gas in a jar. This would need to be done in a fume cupboard because chlorine is poisonous. And we've got an example of sodium on our little spatula there. So there's our sodium, and we can react this with the chlorine. We've actually had a quick look at this before in a previous video, so we won't spend too much time on it, but we put the metal, the sodium metal in there. Adding a bit of water might make that reaction go much more rapidly, but we get lots of light and heat given off. The sodium actually burns, and once the reaction is complete, we are left with a white soluble substance, and that would be sodium that has reacted with chlorine. In other words, we get sodium chloride. Okay, and sodium chloride, as you know, is common table salt. Looks a bit like this, you've all seen that before, but the other two chlorides for lithium and potassium look very similar. They're crystalline, they're white, and they look very similar to the other two, or to the sodium chloride. Okay, so at the top there we've got lithium chloride, we've got the sodium chloride in the middle, and at the bottom there is our potassium chloride. And again, always a good opportunity to practice balancing, so let's have a look. We'll use the example of potassium this time. So potassium reacting with chlorine, which is Cl2, gives us potassium chloride, and we can just balance that quite easily. Put a 2 in front of the potassium chloride and a 2 in front of the potassium on the left, and that is now balanced. Quite a lot we've gone through in this video, so I think it would be useful to do a summary for the group 1 elements. So we've got group 1 from our far left of our periodic table, and the first thing we talked about was the idea that they are called the alkali metals. They make alkali, or they make an alkaline solution when they react with water. They are soft reactive metals, and the atoms in all of these elements have 1 electron in the outer shell. That determines the kind of reactions they do, and as you go down the group, the elements are more reactive the further down the group you go. We then looked at the reaction with oxygen, and we said they react quite easily and they produce metal oxides. Here's an example of one of those reactions in a balanced symbol equation. So sodium plus oxygen gave us sodium oxide, and there's our balanced equation for that. And we said that the metal oxide was a white powder, and it's the same appearing white powder for all of the elements there that we've looked at least the first 3 there that we looked at. The reaction with water, we get metal hydroxide plus hydrogen given off, hydrogen as a gas, that's why we get the fizzing sound. And here's an example of a formula equation. So we've got potassium and water gives us potassium hydroxide, and if we balance it, it would look like that. Then we looked at the reaction with chlorine, chlorine being a yellowy green gas from group 7, and one example would be lithium plus chlorine gives us lithium chloride. We can balance it quite simply like so. In fact, that's not correct, is it? Yes, it is. Okay, so that's the reaction with water, oxygen and chlorine. Might be worth adding here just to make sure we remember that the alkali is produced for the reaction with water. But that's a summary of the group 1 elements from the periodic table and the things you need to know.